Hello and welcome. This is a video for teachers about a data game called Floyd's of Fargo. It's about a fictitious insurance company. You're insuring drivers against flat tires. The object of the game is to make as much money as you can in 10 turns. Since the only control you have is the price of the premium you set, making the most money amounts to finding the best premium price. Now, I assume that you've watched the 2 student videos and played a few turns. You understand how the game works, the basic mechanics, and how students will use the table and make graphs, so we're going to skip all that. First, let's talk about the math. The underlying analytic optimization problem is suitable for Algebra 2, Pre-Calc, or even Calculus. But we won't be taking that approach. It's written up in the teacher guidelines if you want to see it. Instead, we'll take an empirical approach. We want students to make useful graphs of the data and use that data to make decisions about premium price. When you discuss this graph with students, point out that the thing you want to know, the money you get, goes on the vertical axis, and the thing you can control, the premium price, on the horizontal. We want students to really understand this graph, so you'll want to probe for understanding. Ask questions like these. What does this point represent? Why is the ending balance low at very high premium prices? Why is it low at low premium prices? How can it be negative on the left but not on the right? Make sure students are connecting the graph to the situation with the flat tires. Get them to talk about customers and premium prices, not just points, coordinates, and equations. Here are more questions to consider. Why don't all of these points line up on a nice curve? How accurately can you tell the best premium price? If you charge 50 cents, what's the range of money you expect to get? You can use DG to make other graphs that can reveal things about the situation. Watch how I do this. Let's look at the number of customers we get as a function of the premium price. Wow, it's a straight line. And look at the direction. Have students explain why this makes sense. That is, the more you charge, the fewer customers you get. We can put a movable line on the graph. Does the equation make sense in slope-intercept form? Sure, the intercept looks like it's about 2,000. That's how many people will take your insurance at a price of 0, that is, when you give it away. The slope is rise over run. 2,000 is the rise, and 1 is the run, for a slope of negative 2,000. Suppose you want to put a non-movable line on the graph. For that, you use plot function. Select it from the gear menu in the graph and enter the function you want. Let's make another graph. We expect that the more customers you have, the more flats you'll get. This graph shows that we're right, but look how it varies. If we put a movable line on here and make sure students can explain why we should lock the intercept, we can see that the probability of getting a flat is about 0.002. We have a busy screen now, a table and 4 graphs. I'll select one of these points here. Notice how the same data gets selected in all data views? This can help students cope with all this information. Understanding these graphs helps students really understand how all these quantities are interrelated and is good practice for more advanced math. Students can even take what we've done, like the 2 lines we just plotted, and do theoretical calculations. For example, suppose we have a premium price of 50 cents. How many customers will we get? Well, 1,000 each turn, or 10,000 altogether. That's $5,000 income. How many flats will those 10,000 drivers have? 0.002 times 10,000 is 20, so we'll pay out about $2,000. That leaves a profit of $3,000. If each group did this with a different premium price, you could plot a class graph of expected profits. Using specific numbers like this is good practice before using variables. Here are 2 things to watch out for in class. First, many students don't have experience with insurance. It's worth a discussion before you start to play. Second, some students try only a small range of premium prices, like from 50 to 75 cents. Encourage them to try a wider variety. You can sometimes tell more about the shape of the curve when you can see more of it. Speaking of the curve, This looks like a parabola, and it is. You can use the plot function command we talked about before to plot it. Vertex form is easiest. And if you use sliders for parameters, you can adjust it dynamically. Good luck!